This is an alignment. Notice around here we always have a title block for any sheet, any drawing, any diagram that we may have. So here's the title block, like I said, and then there's some information here that we'll look at in a minute. In this section here, we have the profile elevation for the pipe and the grade as well. And then in here, we actually have the alignment. And above the alignment, we have some information here as to the survey, who conducted the survey for each one of these sections, the owner of each one of the properties, footage, we have wattage, and then the terrain information as well. So I'm going to start with the title block. Let's zoom in just a little bit. The title is comes near to Chester, and this is an alignment for an 8-inch diameter pipeline. Is in Tyler County, Texas. It tells us the scale is 1 inch equals 500 feet. Drawing number, sheet number, for example, this one is 2 of 5. The first one was 1 of 5, etc. In here it tells us who checked the drawing, who drew it. Any revisions that have been made on the sheet itself are listed over here, and of course you'll have numbers 1, 2, and 3 for each one of those revisions. In here it just lets us know that we assume that the pipeline is 4 feet below grade, and then it also tells us that the depth is 5 feet on creeks, highways, and railroad crossings. And note, all elevations were taken from United States Geological Survey maps. Any emergency values here, there's none. And here we have the legends to let us know what each one of the different lines represent. Any other pipe specifications, we are not given any. And then any pipe specifications and test requirements are listed here. Okay, so that's for the profile. Okay, so the second part is the profile. It tells us that horizontally 1 inch equals 500 feet and vertically 1 inch equals 50 feet. So from here to there is 50 feet, so that would actually be 1 inch. 1, 2, 3, 4, 5 to get to this line, which that actually would measure 1 inch in the drawing itself. So this is 100 feet above sea level. Then of course each one of these lines represents an increment of 10 feet. You may notice that some profiles, let me show you the first one, I think does it. Here, some of these profiles will shift up and down depending on the elevation. So obviously this pipe went down deeper than the 250 feet that was listed here at this line, and so that just means that from this line forward they have shifted this profile up. So in reality this line here would match this line. It's letting us know that the pipeline went below here, but because we didn't have enough room, then they just shifted it up a little bit. Notice also that there's another shift here. This is on sheet 1. I was showing you sheet 2 earlier. So let me shift back to sheet 2. If we look a little closer to the line itself, you will notice that one line represents, the bottom line represents the pipeline, and then the upper line here represents the grade. That's the actual grade of the land itself. In some points that are going down, there's several creeks. There's a creek here, another creek here, and another creek here, and then this is an elevation, just showing that there's a hill or something to that effect. Also, we have these stations right here. Then we have the alignment itself, which is over here. This is the line here. Notice that the line has 2 little dashes. So if I go to here, it tells us that the line with the slashes here is a buried pipeline. And then just a straight line is the proposed pipeline. So if I look at the alignment here, is the existing pipeline with the two slashes there that every so often, and then the bottom one is the proposed one. In here it tells us that the existing Houston pipeline is 12 inches in diameter. And of course, we know that the one that is proposed is 8. Notice these markings here. Every time the pipe changes direction, in other words, has a different angle, you will see that you have these little dots. Let me zoom in just a little bit. These little dots, that just means that the pipeline is not straight anymore. It just bent a little bit. And each one of these tells us the angle that it broke in. For example, this one is southwest. So this one came from this point. So from this point, it went southwest 81 degrees, 38 minutes, and 50 seconds west. So southwest. Then from here to there, there's another one here. From there to there. If you zoom out just a little bit, you will see that we have a north arrow pointing this way. Okay, so that lets us know that the orientation of the pipeline. And then you will see also that we have a match line. This match line tells us that it's matched 250 foot plus 86.3. So if we shift to drawing number 3, you will notice that the match line here has the same angle and the same information there. So what that means is if we line up these two drawings, and this line right here is matched with the one previously, even if we have to change the angle of the sheet to match it completely, it would give us the continuation of the line itself. Okay, so this one, match line 117 plus 74.9, that would be matched with sheet number 1, and it's right here. Notice that the angle is different and that the north arrow is pointing towards a different directions. So if I was to line these two up, I would have to shift the angle so that the north arrow is pointing to the same directions for both sheets, and I would butt the other line right next to this one, and that would show the continuation of the pipeline. Okay, I was on sheet 2. So I'm back to sheet 2. Any of this information that is given to us here, notice that we have 16A, 16, 17. I will talk about those in a little bit. We have power lines here or anything else. Anything that is depicted here, this hatching that you see here, they should tell us here what it is. It says that it's tall brush. There is a swampy area right here. Okay, and then with each one of these intervals, you have all of this information, giving us information about the property fence. This is a property fence right there. Then we have the top of the creek here. If we look, there should be a creek right about there. There it is. Okay, so there's the creek. So the creek in here would be somewhere around here. Okay, and it tells us that there's a property fence there, there's top of bank, then the creek itself, another top of bank, and then just a matter of looking at this at the same time that we're looking at the pipeline so that we can get a better picture of what that is. Now, for here, the top section of each one of our sheets give us information about the survey, who conducted the survey, who the owner for the properties are, footage for that, wattage, and then the terrain itself. Okay, so let's say we have number 16. Notice this section right there. Okay, that is 16A. The owner is John Sturck, and you have the footage for that is 1,285 feet. And then the wattage, which is like the perimeter, is 77.88. For 16 and 17, it looks like it's all family owned. Then we have number 18 track, which is this one here, and that one is owned by John Kirkwood, and it gives us the area for it and the wattage and so on there. The surveyor for that property here is S.L. Graham, and then it says A19 for how it is recorded in the books. So whenever you answer the questions, just make sure that you look at each one of these carefully, study what the pipeline goes through, and also what is labeled on each one of the markings that you have here according to what is given, what information is given to you here, and also in the elevation itself.